Hi, the first lesson in Algebra 2 is about different ways we can describe functions. So think of it as, I have a graph, my friend can't see it, I need to describe the graph so that my friend has an idea of what's in my picture. The first description is the domain. The domain is kind of like the width of our graph. It's like telling our friend how wide do you need to make your x-axis so that you can fit the graph on it. These will be x coordinates. It's a list of all the inputs that you can put into your function. Remember, if you think about your function as a machine, you put a number into the machine and a new number comes out of the machine. The inputs that are allowed in your function are called the domain. The other new word is range. Range are the outputs. It's a list of all the possible outputs. The range are y coordinates. Every time I input a number into this machine, I should expect the same number to come out. So every time I put a 4 into this machine, I'm going to get an 11. If I put a different number in, I'll get a different output, but I should always get the same output every time I put x equals 4 in. So that's the range. That's a list of y coordinates. In our notation for this, we want to be able to describe in words, but we also want to be able to describe in set builder notation and interval notation. So my verbal description, real numbers greater than or equal to 3 and less than or equal to 7. So what you want to do when you do this is you want two numbers, and your x's or y's are going to be between those two numbers. So the two numbers I have here are 3 and 7. I'm going to put the small number first. So 3 and then 7. If I'm talking about domain, I would use x. If I were talking about range, I would use y. And then I want numbers that are greater than 3 and less than 7. That means my x is between 3 and 7. That means that 3 is less than x and x is less than 7. I also, it says or equal to, so I'm going to put these bars under here, meaning that I would include the 3 and I would include the 7. Same deal if it's a y coordinate. With interval notation, we don't have anywhere that we write x or y, but we still use those two numbers. Instead of putting something in between, we just put the two numbers side by side and then put a comma in between. And then if we're including the endpoints, we will do a square bracket. So we are including the 3 and we are including the 7. So we have square brackets on those endpoints. These two things mean the same thing. The set builder notation and the interval notation are identical. All right, this next description, real numbers greater than 5 and less than or equal to 10. So the two numbers that I have are 5 and 10. 5 is smaller, so I'm going to put 5 first. And then my x or y, depending, and then greater than 5, less than or equal to 10. So x is between the 5 and the 10. We're not including the 5, but we are including the 10. So if I write this in interval notation, I'm going to do 5, 10, smaller number first. I am including the 10, so I'm going to put a bracket on that one, but I'm not including the 5, and what we do for that is we put a parentheses. Right, so parentheses go with this sort of symbol, and brackets go with this sort of symbol with the equal to bar on it. All right, the verbal description, all real numbers, the two numbers that's between aren't really numbers, but we're going to call it's negative infinity to infinity. So our x is somewhere between negative infinity and infinity. We're not going to include the infinities because you can't really be infinity, so we'll always put less than bars on those. Okay, the next one is real numbers greater than -2. If I want two different numbers, well, my smaller number is going to be -2, and that would be, if I want anything greater than -2, that would include up to infinity. So it's going to look like this. It's not greater than or equal to, it's just greater than, so I'm going to use a parentheses, and then the bigger number, infinity. Real numbers less than 50, so that means 50 is our bigger number, and numbers less than 50 would go all the way down to negative infinity. So that would look like this in interval notation, from negative infinity to 50, parentheses because we're not including the 50. So that is the notation we'll use. Here's our first example. What are the domain and range of the function defined by y equals x squared minus 3? If I don't have a graph and I have to answer this question, I'm going to think about what numbers can I input into the function without breaking math. I think about things like, can I input negative numbers? I'm going to get a better color for this slide. So can I input negative numbers? Yes, I can. I could do negative 3 squared minus 3. That's allowed. There's nothing that breaks math about that. Could I input 0? Yeah, I could. So negative numbers work. 0 works. 0 squared minus 3. Yeah, I'm allowed to do that. There's nothing that's going to break math about that. This would be 9 minus 3, which would be 6. This would be negative 3. So for the domain, there's nothing that's breaking math here. So this is going to be all real numbers, which would be the numbers from negative infinity to infinity, because I can't break math by plugging a number in. And then for the range, we want to look at what numbers would be outputted. I'm going to go back a little bit. In interval notation, this would be negative infinity, comma, infinity with parentheses. So I like thinking about what's the biggest thing that could be outputted, and what's the smallest thing. So I'm going to imagine putting in a very big number. So if I put in like 10. 10 squared minus 3 would be 100 minus 3, which would be 97. But I can see almost right away that if I tried 100, that's just going to keep getting bigger. So this biggest number is just going to get bigger and bigger and bigger. So the biggest number is going to be infinity. I can't stop this thing from growing. But the smallest number, at first you might think, well, let's try a negative 10. If I do negative 10 squared, that's 100. Oh, so that's actually fairly large. So let's go even smaller. How about we try 0? Well, 0 squared minus 3 would be negative 3. Can I get anything less than negative 3 to come out of this function? And what I know is that if I square any number, it's going to be a positive. So if it's negative, it squares and is positive. If it's positive, it squares and becomes positive. So actually, negative 3 is as small as I can go. If I were going to write this in interval notation, I would say negative 3, actually in set notation first. So my y-coordinates are between negative 3 and infinity. I am including the negative 3. I'm not including the infinity because it's not really a number. And then I would use a bracket on the negative 3 and parentheses on the infinity. It's easier, I think, when you have a graph. When you have a graph, what you're doing is you're saying, okay, I need to find the domain. This is the same function, but now we're looking at a picture of it. So we put our pencil on the furthest left-hand point. That point continues on to the left. It has an arrow on it. It's going off the graph. It's going to continue on to the left. So my domain is going to start at negative infinity. And then I put my pencil on the furthest right. That continues on to the right, so that would be to infinity. We did this with just the equation, but I think it's much easier with the graph. For range, because range is y-coordinates, range is describing how tall our function is, we're going to start low, and the lowest point has a y-coordinate of negative 3, and there is actually a point there. So the y-coordinates are going to go from negative 3, and then we go to the highest point. Well, there's a tie, but they're also both going to infinity, so that would be our range. We went over this real-world problem in class. I'm going to skip it for now and go to these graph problems. These are ones that I asked you to do in class, and I will quickly go through these two. The domain is going to be furthest left to furthest right. So the furthest left is negative infinity because it's going on. And then the furthest right is positive infinity. And in in interval notation, that would be negative infinity to infinity. And then for the range, we start low to high. Well, the low point has a y-coordinate of 0, and there is actually a point there. And then it goes to infinity because that arrow is continuing up. That's letter A. Letter B, left has an arrow, right has an arrow, so the domain is negative infinity to infinity. And then the range, the bottom point has an arrow, So the range is going to start at negative infinity. The top point looks like it has a y-coordinate of about 4.5. And there is a point there. All right. Another description that's helpful is being able to find the X-intercept. The X-intercept is the point where the graph crosses the X-axis. So for this graph, it crosses the X-axis at 2. The y-coordinate there is 0, so the ordered pair would be 2, 0. For the Y-intercept that crosses the Y-axis, there will always only be one Y-intercept. There might be more than one X-intercept, but there's never more than one Y-intercept when you have a function. So we're going to look at this graph to find the X-intercept. The X-intercept is 320. And what 320 means in the context of this problem is that our y-coordinate is 0. So we have 0 gas. And the x-coordinate is 320. We have gone 320 miles. So when we run out of gas, we will have driven 320 miles. That's what the x-intercept means. The y-intercept is where this graph crosses the y-axis, so it would be 16. And what 16 means is when we have gone 0 miles, we have 16 gallons. So that means that when we start our journey, we have 16 gallons of gas. If you have to find an x and y-intercept without a graph, then you can make use of, so from finding the x-intercept, what I need to make use of is that y would be equal to 0 whenever I'm finding the x-intercept. So I'm going to rewrite this exact same equation, except I'm going to use 0 equals absolute value of x minus 3. And then I recommend setting up those railroad tracks so that you can solve for x. We're going to add 3 to both sides. And then we have 3 equals the absolute value of x. Absolute value means how far is that number from 0. So one number that is 3 away from 0 is 3. The other number is negative 3. So both of these two numbers, if you take the absolute value, you get 3. There are 2 x-intercepts. It's okay for there to be 2 x-intercepts, but there's only ever one y-intercept. The y-intercept is going to be when x is equal to 0. So there's only going to be one, and you don't even have to do algebra. You don't need railroad tracks because all of the math is on one side of the equal sign. So 0 take away 3 would be negative 3. So the y-intercept is negative 3. This example, the x and y-intercepts of this one, remember this would be g of x is the notation that means y, so y equals x squared minus 4. To find the x-intercept, I'm going to make y equal to 0. So I have 0 equals x squared minus 4. I'm going to move the 4 over, so I have 4 equals x squared. And then I'm asking myself, what number squared is equal to 4? Well, one possibility is x equals 2, because 2 times 2 is 4. But another possibility is that x is equal to negative 2. So there are 2 different x-intercepts. And then for the y-intercept, we're going to make x equal to 0, and we don't have to do any algebra. We're just going to do math. So we get y equals 0 squared minus 4. So the y-intercept is going to be negative 4. The last thing we talk about in this section is positive and negative intervals. Positive intervals are going to be the x-coordinates when your function is above the x-axis. So this function starts out below the x-axis. It crosses the x-axis at negative 5. It crosses the x-axis again at negative 1, but between those two values, it's above the x-axis. These are going to be x-coordinates. So this is a positive interval. There's another positive interval at 4 when it crosses back up above the x-axis, but then it keeps going up above the x-axis forever. So we would go from 4 to infinity for those positive intervals. Negative intervals are going to be when the graph is below the x-axis. So it looks like it crosses to above the x-axis at negative 5, but before that, it is below the x-axis. That's interval notation. And then between negative 1 and 4, it's below the x-axis again. Just want to point out that I'm not going to include negative 1 because the function is 0 at that point. It is not negative, it is 0. All right, I'm going to stop there. I'm going to do a little summary of what you should have known. You know the domain, range, X-intercept, Y-intercept, positive intervals, and negative intervals for functions.